Machine learning is the process whereby computers learn to make decisions from data without being explicitly programmed. For example, learning to predict whether an email is spam or not spam given its content and sender. Or learning to cluster books into different categories based on the words they contain, then assigning any new book to one of the existing clusters. Unsupervised learning is the process of uncovering hidden patterns and structures from unlabeled data. For example, a business may wish to group its customers into distinct categories based on their purchasing behavior without knowing in advance what these categories are. This is known as clustering, one branch of unsupervised learning. Supervised learning is a type of machine learning where the values to be predicted are already known, and a model is built with the aim of accurately predicting values of previously unseen data. Supervised learning uses features to predict the value of a target variable, such as predicting a basketball player's position based on their points per game. This course will exclusively focus on supervised learning. There are two types of supervised learning. Classification is used to predict the label or category of an observation. For example, we can predict whether a bank transaction is fraudulent or not. As there are two outcomes here, a fraudulent transaction or non-fraudulent transaction, this is known as binary classification. Regression is used to predict continuous values. For example, a model can use features such as number of bedrooms and the size of a property to predict the target variable, price of the property. Note that what we call a feature throughout the course, others may call a predictor variable or independent variable. Also, what we call the target variable, others may call dependent variable or response variable. There are some requirements to satisfy before performing supervised learning. Our data must not have missing values, must be in numeric format, and stored as pandas data frames or NumPy arrays. This requires some exploratory data analysis first, to ensure data is in the correct format. Various pandas methods for descriptive statistics, along with appropriate data visualizations, are useful in this step. Scikit-learn follows the same syntax for all supervised learning models, which makes the workflow repeatable. Let's familiarize ourselves with the general scikit-learn workflow syntax before we explore using real data later in the chapter. We import a model, which is a type of algorithm for our supervised learning problem, from an sklearn module. For example, the k-nearest neighbors model uses distance between observations to predict labels or values. We create a variable named model and instantiate the model. A model is fit to the data, where it learns patterns about the features and the target variable. We fit the model to x, an array of our features, and y, an array of our target variable values. We then use the model's .predict method, passing 6 new observations, x new. For example, if feeding features from 6 emails to a spam classification model, an array of 6 values is returned. A 1 indicates the model predicts that email is spam, and a 0 represents a prediction of not spam.